Hello and welcome back to a new video here on the Ludwig Fusel channel. Now in today's video we're gonna start a new video series where we're gonna write C++ projects. Now these projects might be really small projects that are just gonna last a video, or these projects might be bigger projects that take multiple videos. Now today we wanna actually do a project that takes multiple videos, and I think it's quite interesting and we can learn a lot on this and get a bit of practice for the people that are not that long in C++ than I am, so a bit of a chill project where we're not going to use anything fancy, just the default stuff that C++ gives us, and really simple on Windows, just Visual Studio Code and Visual Studio required, not even Visual Studio Code. I just use it for handling things a bit more visible, but you can also completely go just with your editor and the Visual Studio. I mean, like Notepad on Windows. All right, so what are we going to do? What is the project that we're going to do? Well, we're going to write a expenses calculator. This video is going to last over, or this project is going to last over 4 videos. We're going to today start with the very basic features of an expense calculator. After that, in the next video, we're going to talk about serializing and deserializing. So basically today we're going to do all in memory, and every time we restart the application, our expenses will begin. Next video is then going to about actually saving them to disk and loading it from disk. Then in the third video, we're going to talk about how we can get an export from that data. So we're going to probably write a CSV export for Excel and an HTML export so that we can actually view this in the web page and maybe share this with friends, having a nice report. Now in the last video, we're going to utilize expenses, the expenses.exe, and we're going to add command line options so that you could automate this with a different tool or Python, so that expenses are automatically added by Python. Python calls your application and says which expenses to add. But that's all something that's gonna come in the future videos, so just that you have an idea on what we're gonna do. I think it's quite nice. So we're gonna have a bit of everything here. The only thing that we're not gonna have is UI in this video series in this video project with the next 4 videos. All right, so let's get started creating our project. So for creating our project, I'm going to open up Visual Studio, and inside of Visual Studio in the launcher, I'm going to say create a new project. We're going to go for a blank solution because I want to set up everything on my own. Now you can see that's by default already at the right path, the user tutorial document CPP projects. I already set it up, and now I'm just going to call this expenses. It's important that it's the same name than the folder that I've already created for Visual Studio Code, but it's also important that it's completely empty. If it's not completely empty, it's not going to work, and Visual Studio is going to complain. However, it was empty, and you could have seen this a few seconds that we have created the SLN and the .vs folder. I want to quickly make sure that I initialize this to a Git repository, because we are developers, we always work with Git, and I can't really say how important this is to have your Git managed correctly, and it's also important that you have your Git ignore. I often see that this VS folder is on Git, so that's not good. So we basically wanna remove VS temp files. So Visual Studio temp files shall be removed, and all of the temp files are in /vs, current folder, subfolder vs, and there you go. Everything is grayed out, it has been excluded. That's what I want to do. Now inside Visual Studio we can now add our first project, new project here. Now I want to have an empty project here for C++, and I'm going to call this one expenses. Since I'm calling it the same, I could have also created it directly, but I want to just quickly call this one expenses and just create this. I always tend to do this separately, just out of good practice. Now I'm going to switch the view here, and I'm going to go into the properties of the project, because we need to set a few things up. First of all, I want to get rid of 32-bit. I don't want to maintain 2 configurations that potentially break. So yeah, nowadays nobody uses 32-bit, so we have a reason to remove it, because everything that you have needs to be maintained. Now it's again important that this is on all configurations and on x64, so that we can customize our paths like we have done it in C++ tutorial, just because I don't like the output and how Visual Studio does things. So I want to have all of my build output in the build directory, then it's going to be platform minus configuration, and then all of my binaries are going to be in the subdirectory bin. Important is that you have the slash at the end. I'm going to copy that path, because you also need that path for the intermediates. It's going to be the same. The only thing is that they are going to go not in the bin directory, they're going to go in the OBJ directory, but we could have multiple projects in the solution, so I want to have it in a project name subdirectory. We're not going to have multiple, but this is something that I would recommend that you always do, just out of good habits to do it properly. Now, next thing that I want to do is I want to switch this to CPP20. We're not going to use CPP20 features. Why should I not use CPP20? It's just an application, and you always should go with the latest stuff. It's just my recommendation. All right, so everything else is set it up correctly. Now what I want to do is I quickly want to add a main.cpp so that we can check that everything is working. So let's create that one, main.cpp. Let's hashtag include IOStream in here. To get started, let's do a int main, and let's just do a quick stdc out of our friendly hello world and see if this is working. If it works, we should get a console which prints hello world, which we got, so everything is good. I'm gonna go do the feedback loop to Visual Studio Code, and you can see that we have a hell of a lot of generated files in our build directory, binaries and OBJ files. And what I want to make sure that I add my binaries here as well, so build output shall also be ignored. I sometimes also see exe files on GitHub, it's not good. You want to ignore your build output. And then we should be good. Git ignore is fine. Expenses, the project files are actually fine, and the main file is auch fine. Since we are not using a build system, we do actually want to contribute all of these. You can see there are a few properties that are configured in here. The filters, we are not using filters, but we are still kind of like requiring that file, and the project settings. So these are all required and everything is good. So we are on track here. And now in theory, we shouldn't need to change anything from now on. All right, so let's get started by developing our expenses application. Before we can start developing our expenses application, we need to have a vision on how the expenses application shall work. Now, what I want to have, my expenses application shall be in a command line style pattern. So the idea here is that the expenses application is not kind of like visual or it's greeting you with something. It's always going to greet you with a command line. I want to indicate the command line by a dash. And then what you need to do is you need to enter a command with some optional arguments. This is kind of like the idea. Now, what of these commands shall be available in an expense calculator? Well, we should be able to add expenses. We should be even to delete expenses or remove them. Rem, rm, I don't know. I think I just want to call them del for delete. So we should be able to add some, we should be able to delete some, we should be able to list them, and we should be able to evaluate them to basically see how all the expenses come together. And at some point we also need to terminate our application, so we need an exit command. And while the exit command is not executed, all of the other commands are basically working. Now, what arguments do we need? First of all, I want to have a label for each expense. If an expense has a label, it's basically kind of like the text for it. Then we need a value of the expense, and I also want to be able to kind of like, maybe let's do the value like that. And I also want to be able to indicate if this is a plus or a minus expense. However, this shall be optional, and it shall default to being a minus. So default is minus, so by default expenses are always going to be subtracted from our balance. And if we want to manually add a positive balance, I want to do this explicitly by saying like label plus expense. And this is kind of like the idea. Deleting is simple. For deleting, we just going to need a IDX. Or actually maybe even a label. Maybe we want to delete by label. Deleting by labels might be a bit better. I mean, yeah, kind of like if I have multiple labels, it's a bad idea. But I think deleting by labels is a good idea. Now, what shall list does do? List does not need any arguments. It will just print all of our expensive. Evaluate does not need any arguments. It will just print out the total evaluation of the values. And exit shall also get no values. It should straight away exit the application. All right, so now that we have all of the syntax, we need a way to actually now read them in. Now, the general idea or the straightforward idea that you would do is you would use cin and an std string. However, the problem with an std string and cin is if you are doing it like that, like std cin into a string, we of course need this. std string command, for example, if you would do it like that, it wouldn't really work, right? I can show this to you. I'm basically just also going to output the command, and instead of doing that, I want to do it properly. Let's do the cin and the output of a command, and I can show you what the problem is. Now, if I enter hello, it's not a problem, it works. However, if I enter now how we want to do this, like add label plus 0.0, you're going to see that we're just going to get the add, not the label, not the plus, not the 0. Now, we could see this as an advantage because it's already like splitting the arguments at the space. However, the way I want to architect the application, it's actually bad because I want to put that responsibility behind something else. I don't want to have the responsibility of of separating the commands with the arguments on the cin. Says multiple options because this basically means that we need to have a stateful way of parsing our command line. We basically need to know when the last argument was there, that we basically go out in a different state, and managing all these states can get quite complicated. So what I rather want to do is I rather want to read in the whole line and later on separate the whole line into multiple arguments. So we're gonna see how we're gonna get to this soon. All right, so how are we going to do that? Well, there's actually an option to call that is in the background calling cin as long as there is no new line. It's called std getLine. std getLine basically, it just executes std cin until it finds a new line. So first argument is std cin, second argument is our command, and if I do it like that, it's going to get the whole line. Now, still, if I provide, now I have written gallon, not hello, or hell, or whatever. But if I do like now add a few arguments in here, you can see that we are always going to get the whole line, and that's the whole point that we need. All right, so that's sorted out. Now we just need a way to kind of like execute this in a loop. So this is kind of like, oops. That's kind of like what we need to do in a loop. So what I want to do is a while true. So as long as my application is running, I want to do that, which shall already give us some options. The only thing that's left, that's missing is a new line, because it's now really not putting a new line there. So if I go in here, I shall provide a std end line so that we have a new line, and I also want to have a space in here. So that's already good. This is kind of like getting user input. And now the next thing that we need to do is, after we have getted that input, we need to now actually check the command. Now, how do we check the command? Well, I'm just going to do a big if-else statement. So if command is add, else if command is delete, else if command is list, and down here, else if, oh, now if double else if, we now have also eval. And we have exit. Now exit is already quite simple how we can implement that. I'm basically just going to break out of the while loop. Now the other else statement is also required. I want to say if a command is not recognized. So command cmd is unknown. So we're going to do it like that. Then we're going to also provide an end line here. Command is unknown, exclamation mark. And now we have a way of actually now running our application. Now, if we can do this, we can quickly, I mean, we don't get any feedback. That's not good. Maybe we should get some feedback here. std cout. Yeah, no, I'm gonna echo out the strings, or you're not gonna see that the if works properly. Let's add a few of these lines for delete as well. List, eval. No, exit, we don't need one because we can already see that we are breaking out of the loop if we are gonna go and exit. So let's see if this is working. Now let's try it out. If we do add, we get an add. If we do del, we get a del. If we do list, we get the command is unknown because I have mistyped. If I do list, we get list. Eval should work and exit should close. All right, that's all working. So that's good. However, I can show you how when it's not working. If I try to use add like that with caps, it's not found. It's only found if I do it like that. And even if I do it like that and I'm going to add some arguments, how it's supposed to go, you can actually see that it's no longer working. So we have a problem. So the first problem is that the arguments are not separated. This is because we have getLine, and the getLine means that our command and the arguments are now together in one line and not separated. And the next problem is that the command is not kind of like converted to lowercase. So these few things is what we need to do, and I actually want to factor this out into a own class. I'm going to have an own class that passes our command line. So I'm going to call this class for import arguments. Input arguments.h. Maybe let's copy the name because I'm lazy, and let's write the class input arguments that's doing that. Now, first of all, I do not wanna use the namespaces here for that tutorial or that project here because it's just an example project and not a real product. Now, what I want to use is I want to use strings for storing the arguments, and I want to use vector to store the strings in. Now, vector is basically, if you have not watched the video, it's basically just a list or an array of whatever type you provide. It's a template, so we basically provide as a template argument the std string, which means this is a vector or a list of strings, and the idea is that the vector is also ordered, so there's always guaranteed that the first one is the first one, the last one is the last one, and so on. Just gonna call it one args, so these are the arguments that are stored. Now input arguments shall have a default constructor. We can have empty arguments. We are just going to follow the big three here, and I'm going to put all of these implementations to the default implementations, because all of these operations shall be supported by default, and yeah, that's all good. Now what I want to do additionally is I want to provide my own constructor, and the own constructor is kind of like then going to contain a string, or it's not actually going to contain a string. We're going to use a string view. This is a concept that you shall use as often as possible. So string view, input or line. So we take the line, and this line shall now be parsed as an argument. Now for that I'm going to write a good old state machine, like we have done it previously. I'm just going to use integers for the state. I'm not going to use or do I want to have, I don't think that I can add can I add a enum class just in here? It seems like this might be even possible. Yeah, maybe if it's possible doing it here, we want to do an enum class there for the states. Is that where is that? That's interesting. And sometimes you just need to try something out, right? We can actually call this even already state and do it like that. Interesting way of doing stuff, but it seems like it works. Does it compile? It actually compiles. Interesting. Is it then? I'm really intrigued on where this is stored. Is this a input arguments? Input arguments. No, we can't even access them. Interesting, but that's okay. So it's just available up here, but that's actually okay. So let's call this one state here. And what states do we gonna get? We're gonna get ready for text. So if we are ready for some text that shall be inputted, now what we're gonna have is we're gonna have text begin. We're going to have text. And we're just going to do a simple implementation. I'm going to show you the problem, and then we're going to do the full featured implementation. So we're going to have text begin. So ready for text, and then we have like text begin if we are on a text. All right. So how are we going to implement that one? So first of all, I'm going to say for char c in my line. We can do this. It allows this ranged operators because it's a string view. We can just iterate over all of the characters in there. And to store them, I am gonna actually want to store them in std string. In this case now, not a string stream, even though a string stream might be. Let's do a string stream. I think a string stream is better for doing these kind of tasks. No, I closed it. That was not my intention. Let's use a string stream. Let's do this properly. A string ss stream is, I think, the class for it. All right. Right. So let's do a string stream where we're gonna basically produce text to string stream ss. And I want to switch on my state. And depending in which states we are, we're going to do something. We're going to have the case state ready for text. And we're going to have the case state text begin. And what I basically need to do if I'm on text begin, I need to basically check when what's now going on. So I'm going to do another switch here. I'm going to do another switch on the character now. And now we basically can see what happens from the character side. We do this there as well. So that's kind of like the whole idea of my double nested switch state machine. You know that from my C++ tutorial. Now ready for text is really simple. If we are getting any white space characters, I just want to basically ignore them. And only if I get a normal character, I want to not ignore them. And if I get them, I'm going to basically put a normal character in here to start building up the string stream. And then I'm going to need to change the state, because from now on we are on begin text. And begin text means that we are now allowed to kind of like get white spaces. Now, I'm basically saying state equals state text begin, and now we are basically on here. Now on this state we're only going to get out if we have a white space, because white space means end of argument. What happens if I have an end of argument? Then I am ready for text again, and again, if I have a white space, I need to kind of like save them. In this case I'm just going to say my arguments pushback ss string to retrieve the string, and then I need to clear the string so it's ready for new text like that. Pushback is the function to add something to a vector. And yeah, that's good. Now everything else, every other character that might come, are basically just gonna go to the string stream as a single character. So that is kind of like the idea how we're gonna parse it, and that's everything that we need. That is also gonna ignore double white spaces, because white spaces are not gonna go out of the ready for text, only the first normal character. So double white spaces already taken care of. Now we just need to have a way to access the elements and the size of that. So I'm going to write an inline size t, let's call this one count, so that we get the argument count. And this is going to be const, and I'm just going to return my arguments, and there the function is called size and the y, but I personally like count more. Now I'm going to write a inline std string reference, or a inline const std string reference operator array, so the array operator to get it. Maybe we do want to still provide a get function, so that this is a bit more convenient, so we can also get the argument by doing it like that. Of course I need some index here, size t idx for the index, and then we provide the index here and everything is good. No, I didn't want to duplicate that one. I did wanted to duplicate that one and call this one operator array. And instead of doing it like that, I do actually want to get for that index. Just like that. Now we have a way to access the elements, and now we can try out if this is working. So let's go into my main file and let's include that one. I don't think we need that anymore. We already know how that application shall work. So let's include my input arguments here, and let's now pass the get line with the input arguments. Now I want to call this one just line and not cmd. For command, I'm just going to call this one line. And what I want to do is I want to say import arguments in args, and is in args are going to be constructed by the line. And now we have the input line arguments, and now the std string command is basically the first element in this input line arguments. Now let's maybe make a breakpoint here so that we can see if this all works correctly. Let's press F5 and see what we got. Now if I do something like, we're directly going to try this out, add dd, xx, kk, whatever. If I do it like that, we hit our breakpoint. You can see that our command is at, even though the line was longer, and the input arguments has a vector with add dd, kk, kk, and I also had xx, so xx was actually missing. This is something that happens quite commonly when you write state machines, because I tend to forget these. I think the null terminator is not returned by this iteration. So what we rather want to do is, if the loop has finished, we want to quickly check if my state equals to state text begins. So if we are currently parsing text, and if this is the case, then we do just want to do and put out the last string so that it gets added to there as well. So add dd, xx, aa, so aa should be the last argument that we got. And you can see now the AA is in here, XX is in there, DD is in here, and add is in here. And if we remove the breakpoint, we should also see that the application is now correctly recognizing this as add. This hasn't worked previously. Same with delete. It should actually work like with all commands, because you could add like everything that you want. The only thing that's not gonna work is if I do like capitalized or like ADA. This will not work. No, it would still be ADD, not ADA, but still it doesn't work. ADD, it also doesn't work. No, only add works. Now this is something that is also not good. We want to actually fix that. Exit is still working, of course. We haven't tested it, I think, but yeah. Now how can we do this? How can we convert this command to lowercase? In C++, there isn't like no to lower or something. Like in Python, there is nothing. To lower, it doesn't work. What you need to do is you need to manually transform that, but the standard library has us covered. There's something called algorithm that provides several default algorithms in a functional pattern. So what you can do is you could use this std transform function. Now the std transform function takes in a first, last, and destination iterator. The first iterator is the first element that you want to transform. The last iterator is the last element that you want to transform, or like one before the last element, because the last or the end iterator is always kind of like the stop where it stops parsing. And then the destination is the start iterator where you want to transform to. You kind of like have start, end, where do I want to transform to? And then you have a transform function. So the function that shall do the transformation. Now, it's quite simple. For a string, we just say cmd begin to get the first iterator and cmd.end. This is now basically iterating over the whole string, so each character will be transformed. And where do we want to transform it to? Well, basically, we want to transform it in place. So basically what it does, it reads from begin. Or first of all, it takes like it says like iterator is equal to begin. Then it basically calls your function with the value of begin, takes the returning value of your function, and it writes it to there, and then it increments like both iterators. So it is kind of like working. It can do this in place. It's possible. Now the last parameter that we need to do is we need to provide a function. Now the function itself could be written here. So you could write a char function like to lower, which takes a char c as an input argument. This works. And then you can just provide the toLower function in here, and this will automatically call the toLower function. And what you would do is you would convert this to toLower. However, what you can also do, you can provide this as a lambda expression. So you could do like things like char c and return c then in here, but convert it to lower. For that case, I prefer the lambda, because it is a bit better to show this to you. Now, how do we convert this to lower? There is a std to lower function available that can convert a single character. However, the std to lower cannot convert a string, sadly. std to lower is just for characters, but if we are using it in combination with std transform, it can transform a whole string to lower. And if we are doing it like that, we should get our command string transform to lower. So if I do like add dd now, you can see that add is now actually recognized every time. No matter how I write my add, it will always be recognized because it's converted to lower. Same exit. Let's go. Works for all comments. All right, then let's get. Now the next thing that I want to do is I want to now actually extract my arguments. Do I want to do this? Well, I could actually do something with input arguments and just remove it. However, I don't want to do that. I want to actually abuse that class, and what I want to provide here is I want to provide a function called sub, and yeah, that's a function.sub is gonna be it's gonna be easy. It's not gonna be too much involved. We have a function that's going to return an input argument. It's gonna be gonna call a subset, and I want to kind of like say an index I and the size t count, and count is gonna be set to std numerical limits of size t and the maximum value. Now the general idea here is that you're gonna provide a offset. I'm going to call this one offset. Offset and the count. So the count is kind of like how many elements shall be transferred at a maximum, and offset is kind of like the offset where you want to start, and it's going to produce a subset of these arguments. Now, the general idea, it's not actually that hard to do it. We're just going to implement this in here. We're just going to get a new instance. So let's call this one subset. Let's just call it subset as well. And the subset is going to be returned. Now, the first thing that we need to do is we need to take into account our offset. So how am I going to do this? Well, I'm going to say auto iterator, and iterator is going to be equal to m_arguments begin. And I'm basically going to add the offset to the iterator. This actually works from a standard library with the vector. That's basically moving the iterator as many times as offset specifies. If it's 0, it's going to stay at the begin, and then it's basically going to move on. And what I now basically need to do is I need to have the count. So basically what I'm going to do is I'm going to say for, I'm going to do something like for size di equals, we do this differently. While count minus minus, while we decrement count, we post decrement it, so it basically starts if we would provide in 1, we get the value 1, so and then it's gonna get decremented, so it's need to be post decremented. So while we are doing that, and while our iterator is not equal to m arguments end, because I need to catch that the value of count is bigger than what's actually in there. The offset itself, I'm not going to catch that one if it's out of range. You need to verify that on your own, but however, that count shall be an optional argument, so I actually want to verify that iterator does not equal to the end. And basically what I'm going to say is, I'm going to say subset dot m arguments dot pushback dereferenced iterator, actually like dereferenced iterator plus plus. So same idea than the minus minus here. So we're going to get an old copy, but we're going to increment the iterator. And this is basically then pushed to the next subset. So this shall be able to give us a subset of these arguments. It shouldn't be a big deal. So we can do something like auto args, and args is basically in args of a subset with an offset of 1. I did wanted to provide the maximum size just out of convenience, and if I do F5 and maybe can I get a breakpoint in fast enough? Of course I can't get it fast enough because it's waiting for user input, lol. So if I do like add 1, 2, 3, we can maybe do a check quickly that this is also working. We haven't checked this previously. Now, if I take a look at the in args, you can see that you have like 1, 2, 3, 4, 5. With the add and the args itself, they are just have the size of 5, and we just have 1, 2, 3, 4, 5 without the actual command. So I have the arguments properly factored out. That is good because I'm going to need the arguments later on to pass them on to different subsystems of the application. So now that's all looking good. Now we have a good implementation of that. Now we just need to implement the actual features. Now we have all the argument handling done. We just need to have the actual feature of the application, which is going to be the expense sheet. The expense sheet is going to be the class that we're going to write expense sheet.h. Now class expense sheet, we're going to write it here, and now we basically need to structure all the layout. Now I want to have a struct inside of that class that works and call this one entry. This is going to be one entry of the expense sheet. Now the expense sheet we're going to have a double value, so the value of that expense sheet that we're going to do, and it's going to have an std string label. So value and label, that's quite simple. Let's include a string. And this is basically going to give us all the data that we need. We have a label for that expense and we have a value. And maybe we'll put a value to 0 by default, and the label shall be initialized automatically. Now, what we need to do is we need to implement the expense sheet itself. I always do this that if I have some nested structs, which is the way to go, I would say, because it's an expense sheet and this is the entry of it. So you should always do it like that. And what I want to do here is now I want to store these. These are again stored in a vector because a vector is a friendly thing. We could store it in a map to kind of like have the mapping between the label and the expenses. However, I want to have them in order. I mean, a std map is also ordered. However, I think it's better to do it like that, so we can do a few more things, because a map is, I think, not the right thing for that specific purpose. So we're going to have a vector of entries, and I'm just going to call them one entries. Could just also call them expenses. No, but I do like entries more. So these are my entries. Now, how are expense sheets going to work? Well, expense sheets are going to be default constructible. They are going to be copy constructible because it's just a trivial data types. There's no memory allocation going on. That's all good. And they shall also be copyable. So I deleted that one. No, I wanted to default that, not delete. And now we have everything set up correctly. Now we just need to provide all the functions that we have. So what I want to do is I want to factor out the argument parsing from the actual expenses itself. So what I want to have is I want to have a void add function in here, and this one is going to get a std string view. I don't think that we have string view included yet. It's already kind of like seeing that's in here, but there's no implementation attached to it, and it get issues if it's not included. Label, and we're going to have a double value. That's kind of like what we want to do here. Add. And then I want to have, I'm just going to call them like the commands. And delete is also going to get a string view label. And maybe we want to also provide like a bit of feedback if it has been added, so that we write this class properly, boolean add and delete. Then what I want to do is I want to list them. So how can I list them? I actually can't list them at all. I actually listing all these elements Might be a matter of printing them. No, I want to have a plain list, so I do want to have a list function. However, this list function is not going to write to stdc out. It's going to write to any arbitrary O stream that you can provide. So instead of writing directly to stdc out, we're just going to provide an std O stream reference out as an argument, and this is basically then going to print to it, or let's just call it OS here. Now, evaluating is going to return a double. So eval is also going to be a function. It's going to be a double on the total value of all entries. Now let's actually start implementing that. It's going to be quite simple. So first of all, if I'm adding something, I need to first validate that it's not already existing. How can I do this? Well, I need to find if something is already in here, and good old algorithm has us covered there as well. So let's include algorithm again, and good old algorithm has an std find. How does std find std find works? It needs a first, a last, and a value. The first one is going to be my entries. Okay, I think we need the okay. No, std, wasn't there a std find which provided a predicate? Because we are not really searching for value. What we could... my problem is that I need to actually find an expense with just a name. I could do this by basically implementing the comparison operator for the entry. However, that's not what I want to do. I actually want to have a inline predicate. However, we're going to use find multiple times, so maybe we want to provide this. Yeah, okay, let's do this. Let's provide an Boolean operator or inline bool operator equal const entry right hand side const, and what we're going to do in here is we're just going to return label equal RHS labels. Now these are comparable, and now we can compare them with, or find them with std find. How do I find them? I basically craft a entry e, then I basically assign the label to the label, and then I assign the value to the value. So I basically craft myself a new one, and then I'm going to check bool can insert, and can insert is going to be equal to std find. Std find, the first element, I'm going to search on my entries. I'm going to search from my entries begin to my entries end, and I'm going to search for an entry e. And if this is equal to my entries end, so if this is equal to the end, it hasn't found something, then I can insert. And if I can insert, then I will insert, and I will go to my entries, and they're going to push back a moved version of E, so that we are not wasting too much memory. And then I'm going to return the can insert to basically validate that we have inserted. Yeah, that's kind of like the idea. We might be able... Yeah, no, we're not going to do this. Let's take a look at the delete and implement the delete one. The delete one is quite simple. We're basically just going to say auto... element, and the element is going to equal to std find, and it's going to work completely the same. We're going to search our entries for a entry e. Entry e will be constructed here, and now I'm just going to set the label. The value is, we don't care about the value. And basically, let's return a false here, and if element not equal entries end, so if we actually have now found it, then we can return true, and we can go to my entries, and we can erase the element. Erasing always works with iterators on the vector. You can construct the iterators also with indices, but this is kind of like a way to safely erase all of these. Now we're going to go into the list function. The list function is going to be really, really simple. We basically just say for entry or for... Actually, the list function can be constant, the same with the eval, because we don't change any internals. So let's make them const. And what I'm going to do in here is actually I'm going to say for const entry reference e in my entries. And what I'm basically doing here is I'm going to go to my OS. I'm going to, first of all, I want to provide... Do I want to provide indices? Yeah, let's provide a bit of counting. Let's provide SIST IDX, and I am going to print out IDX++, and then I want to print the label, And how am I gonna do the next thing? I think I'm gonna make a space here, and then I'm gonna provide e.value. However, the value is a bit more concerned because it basically needs to set the position. I can say set. Okay, how can I set the position of it? OS set. Okay. What we basically need to do is we need to set the position of the O stream so that we do not get too many digits after the decimal point. So std O stream precision. I'm not quite sure how this was done. Persian? 9. Precision. So it is std set position. It is in the header called iomanip, and you can basically set the position on how many digits you want to have. Our position seems to be 3 that we need. Is it? When used in an expression, that's the position parameter of the stream out into exactly n. Okay, so we can do it. Normally what you want to do, if you do this correctly, you want to actually restore. You want to first get the position, and then you want to later on restore the position after your function has done something with it. So what you basically do is, I think you can, there is a way to get the state from that thing. Not quite sure how, but there was a way. I think it is at Imbu. No, is it not? I'm not quite sure. There's actually this position field. Well, I think it's a function. Yeah, I think we can get the position like that. Then I can get like the position like that. And then I should be able to... Now I can't access that field anymore, interesting. And I should be able to provide a new position, which shall be 3 in this case. And then I can later on restore the old position. Like that. And this is, I think, the proper way of doing it. I don't know if we would need iomanip for that. I don't think that we actually need iomanip. I'm not quite sure why it didn't suggest that function for me, but I think this is like the proper way to do it so that we can actually store the old position and restore it. And now we should have them printed properly. Alright, now evaluate is also not very complicated. Let's see the implementation of evaluate. And instead of evaluate, how we do that? Well, we're basically gonna write ourselves a double value, and this is gonna start at 0. And then we're basically gonna go for const entry reference e in my entries. And I'm gonna say value plus equals e.value, so I'm accumulating them all together, and then I'm just gonna return the final value of all of my expenses. Now, this is everything that we need. Now we can implement this in our main. Now I'm gonna include my expenses sheet here, and what we want to do here is we basically want to call the correct functions. Now here, first of all, we need an expenses sheet, of course. We have the line here, expense sheet expenses, and we're basically going to work with that expenses sheet all the time. And I'm basically going to say auto value equals expenses dot evaluate, and then I'm going to get the final value. Here I can now use iomanip to basically manipulate the position, because now I'm owning that. The expenses sheet is not owning the stream, however the main is owning the stream, so I'm allowed to modify that. So I can say total, there we go, and then I'm gonna basically say std set position to 3, and then I'm gonna output my value from here, and then everything is good. I do not need to reset it, it's all like in my control. Now list is also very simple. List, we're going to tell the expenses to list that all, and the expenses takes an O stream, so cout is going to go in here and it's going to list all of them. Now add and delete are a bit more involved, because for add and delete we need to parse something. So if command equals delete, it's quite simple. We need to check that our arguments have a count of 1, because it's the only thing that's valid. We have 1 argument, and then we basically can just say expenses delete and provide the string that we want to delete. In this case, it's the first one in that arguments array, so it's good. Adding is a bit more involved, because adding can have 2 or 3 arguments. So let's add all of the 2 possibilities, or maybe let's set them different. Let's do this differently. Let's first of all. Oh no, we're just going to provide. I'm not going to make this too fancy now. Let's say args.count. If args.count is, how can we have that? Like a label and expense, it's going to be 2. Or if we're going to provide something more, else if args.count equals 3. And what we of course always want to have is a bit of error handling. I also forgot to do it down there. So let's remove that here. And let's add the, I don't know why I copied an else statement, but yeah, stdc out and then say something like usage, delete, label. So this is how you use it. And you did not use it correctly. Let's maybe steal that one for above here. Usage, add, label, optional plus minus. And then we have the value of the expense. That's kind of like the idea here. And yeah, now we just need to implement the parsing. So the first one is the label. So let's do auto label, actually maybe auto reference, const auto reference label. It's always gonna be the first one. So yeah, but yeah, now I'm just gonna do it for each of them. So it's gonna be 0. Let's then duplicate that line. I forgot the semicolon, move it down there. So now we also have the label in here. Now if we have 2 of them, it's quite simple. We have the string, so we can do A to F. Can we do A to F? Yeah, A to F is converting to a double. We can do A to F of arguments at 1.cstring. This is basically converting the argument to a double value. So double value is A to F, so we convert that here. And then we can do expenses dot add label and value. And I do wanna, oh no, I assumed this, I didn't want to zoom. There we go. Now we can actually check if that failed. If not that, I want to print an error message. stdc out, failed to add, std end line. And then everything is good. I think delete also checks that, so I could also say if that is not matching, I could also say std out failed to delete. And then we can also again provide an std endl here so that everything works. And that's all looking good. Now the only thing that we need to do is we need to do that down here as well. However, the value needs to be modified, and it's no longer coming from there, it's now coming from 2. And what I want to basically check that if args at position 1 is equal to a plus, then we're basically gonna or not equal to a plus. So if it's a plus, we're going to keep it as is. If it's not equal, the value is going to be multiplied by -1. So it's kind of like inverted. And in the default version, I actually do want to do this as well. Because by default, it's always going to, an expense is always going to be negative. Only if it's explicitly set to a plus, it is not inverted. That's the idea here. And then it's just also just a matter of copy and pasting this over. This also means that, yeah, we could have make this with a hell of a lot of less code duplication. Maybe we should have done this. Maybe let's say if it's that or args count equals 3. And then we're basically gonna have a the label is always gonna be there, but then we're gonna have a double value, and then we're basically going to check that if args count is 2, then the value is going to be that one, and else it must be the other case, else the value is that one, And then we need to do the negation check. And later on we have the insert statement. So this insert statement shall then go in here. This should be good. Now we are going in here to have 2 or 3. We're going to extract a label. We're going to have a dummy double value. Then the value is assigned to the correct one, depending on which type of arguments we have. And then it's added. All right, so this is kind of like the idea that we have here. Let's now try this out, if this is working. I hope it works, but I don't see why it shouldn't work. Let's start by listing. We shouldn't get anything. So let's try adding something. How can we add something? Well, we need a label. Let's maybe add a budget of 100.99. Let's now list. And we have a budget of minus 101 because it has, because the position is not, okay, the position is not the position after the comma. That is bad. Okay, so we need to just set the, okay, can we do this? So std ostream digits after comma. Can we do this? How to specify the number of if you want. Okay, we can do std fixed then. So we need to have like std fixed in here so that it works. But this means if we put an std fixed, it means that we are no longer we're no longer storing our arguments, and I don't want to now blow this video blow it up too much. So instead of then doing all that position madness in here, I mean, we can still do that, but I'm not going to store it anymore because it doesn't really do something, and I want to do like OS std fixed and std set position, which is an IO manip that I've already removed. IO manip, there it is. Set position to 3, and if it's fixed point, I think this is why it then works. Let's see if this is working. But this probably means that I need to do it a bit differently. But now we're gonna have, I think, 3. So budget, and I also forgot to add the plus here previously, 199. I do now list. I probably think, yeah, now we have 3 after the comma because now it's on a fixed point. And now fixed point is no longer saying like all digits. So I need to set it to 2. However, it's gonna work, so I can add a budget. Budget is gonna be plus. So it's gonna be plus 100.99, and if I now list, I get my budget, and now I can add a few expenses. Let's buy a coin for 0.99. Let's buy a bread for 5.99. Let's add a milk for 1.99. And now let's list all of our expenses, so you can see that we have a budget of 199. We've bought the coin, bread and milk. And now if I do an eval, we're gonna get our total that we have. Oh, of course it's now because it's fixed point and it doesn't count leading zeros. That's bad. But I think the value is kind of like correct. I mean, and I'm assuming that C++ can do math, but I am gonna quickly verify. 9202. Is it not possible to count leading zeros? Is there a different there's not only fixed and scientific, is there yeah, there's also hex float, default float. No. C++ std precision count 0 fixed point. So can I do this? Position. Yeah, of course it's not going to all. Can I count the 0? It's not possible. setf. Float field. What is float field? So maybe what we need. No, wait, float field is the one where it goes. I don't know. Why is it always that? I mean, I think the like FMT has versions of doing it, but I don't want to use FMT. I think that we are just not going to set anything of this at all, and we're just going to take it how the library is going to present this to us. Maybe we are even hurting this too much. Again, for a bit of a hunch that it works if we are just doing it like that. But yeah. So let's see. Now, how do we do this? Now let's add a budget of plus 100.99. Let's add a coin again of... Now let's do a quick list and see how it looks. Yeah, 9.99 is good. So if we now do an eval, we should also get the same value. Now if I now add a coin for .99 and list that one, yeah, that's still good. If I now do an eval, I just get 100. So that's actually okay. I can live with that. The only problem is that if we're getting... I mean, the problem is if I would... But the problem is only going to arise if I'm an idiot and add in wrong values. If I add like a KV for 0.9999999, if I add somebody's like that and then do an eval. Oh, eval is still going to be good. How is list going to be? It's also going to be... It's converting itself, okay, so yeah, I mean, it's not 100% nice. Let's maybe try delete of this should fail, but that one shall do it. So yeah, listing works, eval works, so that is all working. We can add, delete, list, and do some things. And now I'm going to show you how to break the application. Budget for, if I'd say budget for month. If I have like a 99 cents for a month, you can see it's no longer working. However, we can make it work and we can make it crash if we do it like that. Add budget for 99. Doesn't work. That one works. And looks interesting. Right? We provided 99, but we got minus 99. Seems like it's good. Let's see. I mean, it is actually good because it's basically ignoring that, lol. But you get the point, right? It is not doing the right thing. If I would wanted to have an add-in here, right? The thing is, it doesn't work, right? It doesn't work like that because we only support strings without spaces. Can we add support strings with spaces? I actually want to support spaces like that. So, okay, I want to support that one, but this is not going to work. Let's add support for that one in our input argument parser. How can we add support for that? We can have text begin, and we have text begin ignore spaces. How do we do text begin ignore spaces? Well, basically we ignore spaces if the first character is a quotation mark. Then we basically just going to set our state. We're not going to store the quotation mark. And then we're going to go into a different case. Text begin ignore spaces. Switch on C. And now we can only go out of that if we have a quotation mark. And the thing is that I am only going to go out if there's a quotation mark. And that's a rule. If it's not any with a quotation mark, it's ill-formed. Ready for text, break, default. It's going to add to that one, it's going to break. So that's kind of like the idea. If it's not going to that, so we don't need anything like that down here because this is already catched. And this should add support for that one. So now I should be adding for budget for May. Budget for, what do we have? No, we don't have May. Yeah. So let's say maybe 0423. And then we're gonna add like 1,000 budget. And it doesn't work. Why? Why is my code not working? Oh yeah, I see. Good old friendly forgot to add your break. If I don't take a break, it's not good. It's really not good if we forget a break like that, because it's basically doing both expressions. Budget for... I don't know why I'm on May currently with my mind, but... $1,099.99, and this should now work, and also should have the whole budget in here. And I can of course also, let's maybe add DD for 0.5, and then I can delete DD, listed, evaluated, and exit out of it. Okay, so that's everything that we need. That's everything that we need to do for today's video. We have implemented an expense calculator. And in the next video, we're going to make sure that the expense calculator is actually being able to save expenses to disks, and also to load them from disk. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.